Module 3, Topic 3, Activity 1.5. So in Lesson 1, Activity 5. Page 166. So yesterday we talked about, or in Lesson 1.3 and 1.4, we talked about total price versus profit. And we used this one idea to kind of manipulate an equation and change which variable was the independent variable and which variable was the dependent variable. So in 1.3, we talked about total price and profit. And in 1.4 is when we switched it around. I want you to go back and I want you to look at, I think it's page 162 and 164. So this would be page 162 and page 164. And I want you to see or find the answers that go in these two boxes. On 1.3, what depended on what? Was it total price depends on profit, or was it profit depends on price? And what was our equation? And then I want you to do the same thing for 1.4 using page 164. Pause the video and do that now. All right, this section right here, you either need to come show me when you're done, or I will be around in a little bit to come check it. Teacher check. All right, so if you did this, yesterday, what did you notice about the two equations? Remember, you should be able to write two things? Two things, I think. I think you can write two things about the equations. I believe. Something that is the same and something that is different. Yep, two things. One would be, what are I want to think about how to word this question. This would be like, are the variables and coefficients the same in each equation? Are we using the same information? And then the second one would be, are they solving for the same thing, or are they solving for a different thing? Is each equation used to find the exact same thing, or are they each used to find something different? Number 3, how does examining the situation from different perspectives affect the independent and dependent variables? It just changes. It switches them. It switches them around. Okay? And that happens because what can you conclude about the designation of a variable as independent or dependent? And that's just asking, what makes that happen? What makes them switch around? One, if it's independent in the first problem, why is it dependent in the second problem? And that is just, it depends on the question being asked. It totally depends on the question being asked. All right? I want you to pause the video and see if you can figure out number 2. Give me 2 observations about this equation and this equation. Pause the video and do that now. Okay. You should have said they have the same variables and numbers. We are still using P, T, and 0.2. We just set them up differently to solve for something different. In one of them, we solve for profit equals something, and the other one is total price equals something. Okay? Remember, I need to check this part, so you can do it as soon as you're done, or you can wait until you're done with the whole lesson and then bring it to me so I can check it. Okay? Move on to the next page. Compare the two graphs. So go back and look at your graphs. How are they the same and how are they different? Same. What are they comparing? What two quantities are they comparing? And different, think about how the graphs are labeled on this one. What do you notice about the independent and dependent variables on the axes? And we talked about this. Really, where are they graphed? Where is the independent graph and where is the dependent graph? Pause the video and answer these two questions. Okay, you should have written something like, in the same part, they both use profit and total price. We're comparing profit and total price on both of them. What's different? Each graph is labeled differently. We did talk about this yesterday. Where is independent graph every single time? The independent variable is graphed on which axis? And the dependent variable is graphed on which axis? This is always X. This is always Y. You would think about it as how you plot. And X comes before Y. So it's going to be X-axis, Y-axis. So we plot X first. That's independently. And whatever X is, changes Y. Y depends on what we choose for X, okay? All right, let's move on. Excuse me. Dawson purchased a diesel-powered car that averages 41 miles per gallon. Now, I think I showed some of you this yesterday. 41 miles over 1 gallon. Miles per gallon. Hello. Dependent over independent. Always. It is always dependent over independent when it is a unit rate. So, answer this question. Which one is the independent and which one is the dependent? Let's define some variables. Oh my goodness. Thank God it's Friday. Define some variables. M is going to equal, G is going to equal, this is going to be miles. This is going to be, I'm going to say gallons of gas. Miles is our dependent. It will also be graphed on the y-axis. Gallons is independent. And x-axis. Write an equation to represent the relationship between the two variables. Okay. Remember, this is our isolated variable. So that means it's M equals, if he uses 1 gallon of gas, he's going to go 41 miles. If he uses 2 gallons, so here, look. This is kind of our table. 1 gallon, 40, what did we say? 41. 2 gallons, 82. 3 gallons, I need a calculator. Let's Too early for me to do that in my brain. 246. What am I doing? Oh, dear me, that's not right. 3 times, I just gave you the answer. This is 123, kids. Mueller needs some coffee. Plus, oh, that's not right. And 164 at 4 miles, so on and so forth. What am I doing with gallons and miles? It should be 41, because I go 41 miles for every gallon of gas. So here's the equation I can use. All right, go to the next page. Now, we're going to switch it. Okay? You're going to switch the independent and dependent variables. It looks kind of like this. Now, he uses, hang on, he runs out of gas on a regular basis. He's interested in how many gallons of gas he has used if he knows how many miles he has driven. So now we know his miles. We know how many miles he drives. We're trying to find gallons per mile, essentially. But we're going to use the same equation. Remember, our equation was, move this up. Oh, come on, move all of you at once, please. Our equation was M equals 41G. But now I want it to say gallons equals miles. So I want gallons by itself, so I'll divide by 41. That becomes 1, divide by 41. So my new equation, I should be doing this down in that letter B. Oh, let's finish this. Independent is miles, dependent is gallons. Good. So my new equation is, oh, come on, move me down. So I manipulated it, we rewrote it, and it now says G equals M divided by 41. We still have the same variables. Just the thing is now I'm going to look at my odometer and see how many miles I've traveled, divide it by 41, and then I know how many gallons of gas I've used. What would we expect of the graphs? How are they the same? Well, comparing the same units, however, they are labeled differently. Right? Sorry, I took a drink of smoothie and didn't remember to pause my video. That's crazy. All right. That's the end of the video. That's the end of the lesson. Remember, you have to show me this top part right here that you figured this out. And then I want you to go back to your note in It's Learning and follow those directions. All right? Have a great weekend, and may the 4th be with you.